everybody. My name is Sean A. Allen, and I want to welcome you to the Allen Global Consulting Membership Program. Um, I first want to start out with the requirements. You really need to have a Windows machine with 5 gigabytes of hard disk space, and I would prefer it if you have two flash drives that you can use to back up course material. Depending on the areas that we all decide we want to focus on and follow through, we might also need to download or use some free web-based tools as we see need or as um, is needed. Um, well, a little bit about me. I guess I've been a professional programmer for more than 20 years. And in that time, I've seen so many changes in languages, design models, and expectations from professionals in this area that we're endeavoring in. But the field of coding has some very basic concepts. And once you understand those concepts, you can take this knowledge, this skill set, and apply it to so many things. Coding and programmers are going to be needed for everything now, and we are poised once we understand the fundamentals to take full advantage of that and take our career, our lives, and our families to totally different places. For more on me, I have a LinkedIn, and I'm sure as we go on this journey, we'll learn a little bit about each other. I'll learn about you, you'll learn about me, and we'll solve a good amount of problems and have some interesting ideas of how to solve problems as we go on. So I think there's a lot of things on my mind to get us started, but how about what makes a great programmer? Very few people think about this, and people talk about people who love mathematics, people who are problem solvers and free thinkers. But here's my short list. One, a good positive attitude. Two, a willingness to fail over and over again and not get disheartened. Three, a love for solving problems. I call it that aha moment when you really get and solve a problem. Four, knowing when to be a loner. Um, Programmers spend a lot of time in front of a keyboard and a screen, and if you don't have that mindset where you can lock yourself away for an extended period of time, it might not be the job for you. You might be able to do other things around computers and programming, but an actual coder, I would suggest you think long and hard about it. Number five, question everything. Even when you're given specs, somebody gives you a design, um, ask questions because sometimes they're solving the problem they think needs to be solved, whereas the problem might be something even more complex or even a little less simple, depending on the context, obviously. Six, so a person who really wants to solve the problem for all time, not just for now and not just to get paid or not just to get this job done because somebody's breathing down my neck, but somebody who really wants to solve things. Because that'll take you over when you're spending 50 hours, 60 hours, and still have a love for what you do. Number seven, you gotta be able to check your ego. As a programmer, you're gonna say, "This code is mine. I want to solve this problem." Sometimes you need to stop, reassess if you need outside help. The code might need to change, or the variables might change. This is one that gets a lot of programmers I see in my day to day dealing with them. And number eight, a willingness to learn. I am based in Progress 4GL. but at times I have to talk to people who use SQL. Right now, I'm talking to a guy who is an Android programmer. But again, if we all have these fundamentals, we can talk the same language. And I guess that'll lead us into the idea of pseudocode and flowcharts. These are general concepts that help everybody to understand what's going on when you can talk intelligently in a group or present your work or something like that to other people. Now, as I go through an overhead of basic design, I guess you'll have to read up on some of it on your own. I would suggest you do that. Um, let's think about this. I want you to write the instructions for a 6-year-old kid of how to make toast. Because this is going to be your first homework assignment. It's going to be due at the end of the week, of this week. Assume that all the things that you need to make the toast are available to you in the kitchen or on the counter with the toaster. As you go through that, you might want to think of how you write the sentences and what order and what needs to be done and how it should be done. Remember, you're writing for a 6-year-old, okay? And again, this thing takes planning, and so one of the things I want to discuss, I'll make this introduction kind of brief, but I want to go over certain things. As you design as a programmer, being able to express the ideas that you have so other people can understand it is going to be very important. There's some design models out there. The most frequently used is probably top down. And I use it and I say it's usually like if you're telling a story, right? You start at the beginning and hopefully you get to the end and everybody says, oh, that's a great story, and they understand everything that happened from start to finish. This is a top-down approach. And what it does is it requires you to really think about the entire event or a series of events that have taken place or need to take place, right? So you can express that as a programmer, right? You already know what needs to be done, and you know when you're going to stop for dramatic effect. And now you're checking for listeners' reactions. All of those sort of things happen in your story, and it's the same way when you're writing a program from top to bottom. Okay. The next kind of design methodology is bottom up. This I call like making a cake, right? Yeah. To make a cake, you could have a recipe, but you have to have the ingredients first. So you have to go out, collect all the ingredients so you can make the recipe, right? You add the ingredients together in different steps, and then you make a batter, hopefully, and add whatever needs to be added, and then you put that into the oven, you time it out and whatever, and then you put your finishing touches on it. That is a bottom-up approach because you needed to understand what the final product looked like and then work with the ingredients and then come up to what the final product should be. That's a pretty good example of bottom up. Now there's talk in the field of code on demand. And this comes about mainly because you have a lot of established software enterprises out there. A good one I could mention right off the top of my head would be like Quicken. Quicken has now become a very they're not paying me, but they have a very good suite of problem-solving APIs. And so coding on demand would say, hey, I need to get something out of Quicken. I'll get a group of people to write me some code to get that. So they don't necessarily need to know all the things about Quicken. Um, they just need to know this is what we need right now. It's usually a small area, and right now on demand in the next whatever 3 days or whatever, I want those coders to fulfill this thing, and basically they can tap around and figure out what needs to be done in that time period. um, Sometimes that comes with no planning or planning. Um, in today's world, you're going to hear a lot of buzzwords. People talk about Scrum and Agile and sprints. And basically, it really comes back to the two main methodologies. The only difference is that how we go about um, doing or fulfilling the requirements is a little different. We'll touch on that probably a little later. Um, but what I want us to think about is proper code design. This is the actual physical code. Um, this you might want to take notes on. As far as I'm concerned, I'm very old school. I started in the 80s. A good code should have definition at the top. Any pre-assigned variables or anything should come next. You should always try to gather your inputs. This is stuff coming from files or users or whatever. That should be next. You should then do any processing. This is massaging the data, taking the input, doing whatever you need to do, and then gathering that as a result set. And then you present the end result to the user or put it to the database or whatever. That to me is the perfect um, blueprint of how you should write all of your code. There's some other little tricks I'm willing to share with you, and I think we're going to have an interesting time. I really want to stress at this point, if you don't have Progress for GL OpenEdge installed, we need to make it a priority. And you can ping me and we'll try to make that happen as quick as possible. If you look on the screen, you'll see here I have the Progress OpenEdge desktop open. Um, there's lots of stuff here. There's database, there's tools, but we're just going to start here just so you get a look at it. This is what the editor looks like. There are other tools and options in here. I want to look here in the Pro Tools. And this in Progress, the Pro path, is very important because it defines the hierarchy in which it's going to look for code. So it's going to start in your current directory. We should probably go ahead and make that something solid. We'll discuss that individually based on your computer or whatever. And then this is all the architecture pieces that Progress uses. So if we say had a program called 11-P, if it was in this directory and in this directory, it would first catch this one because it's higher up. And then if it didn't find it here, it would catch it in this one. So this Progress structure allows you to do so many things based on the directory path, and people have used it to trick computers into doing other things. It's really, really fascinating what you could do by just changing the pro path or skipping the path of where code looks. So this is the main editor, and it's what we use a lot in computer languages are the equivalent of a Word document with special instructions in the background. That was an oversimplification, but it's just to give you a general idea. This particular editor has some macros in it, and I've designed a couple of macros, and we'll share that file later on to help you. So if you type something like this, it saves you a lot of typing. I only typed 4 characters, and stuff happened. This is one of mine, and it even has notations and stuff like that. But we will get to that. I hope this introduction works well for you, and that we talk about how things are going to flow. And I hope we get time to meet as a group on Skype. And it would help because the more interaction you have, you hear other people's questions, and you might go, "Oh yeah, I didn't even think about that." That's the way I like to teach, um, so people get the benefit of other people's questions. I think I'll stop here. It's less than 20 minutes, and I hope we have an awesome time learning, and we'll see how we all make this a beautiful thing. Thank you.